we'd like to find the Taylor series for 13 ln of x centered at a equal to 2. Similar to the previous example, since we have centered at a equal to 2, that means that we should be thinking x minus 2's. If I need to be seeing the x minus 2's, I'm going to make x minus 2 show up, but I have to undo the minus 2 by adding 2. So all that I've done, I've forced the x minus 2's, but I have to undo what I did. Sorry, 13 ln. Okay, now we know that the Taylor series for ln of 1 minus x is minus sum 1 to infinity x to the n over n. So now we need to factor this 2 out of the inside piece to make it into a 1. By factoring the 2 out, we get a 2 in the denominator. We need it to be 1 minus, so we'll turn that into a minus. As follows. And then we don't like this 2 that's here. And the way we get rid of that 2 is to remember that ln of AB is ln of A plus ln of B. So I can get rid of that 2 by splitting up the natural log. So this is 13 natural log of 2 plus natural log of 1 minus negative x minus 2 over 2. At this point I can apply my thinking here, but by using the red box in place of x. And so that is 13 ln 2 plus, this is ln of 1 minus something, and my something is negative x minus 2 over 2, and so that means that I have negative sum, we're just using this formula up here, negative sum, 1 to infinity. X, though, is this complicated x, minus x minus 2 over 2, all raised to the n, and then still divided by n. So that's 13 ln 2, so that's really now minus sum 1 to infinity, distribute my n, that makes a negative 1 to the n, that makes an x minus 2 to the n, then we have a 2 to the n, and we also have another n that are in the denominator. And that's good enough. If you expand this all out, you will find a polynomial whose terms have x minus 2, then x minus 2 squared, then x minus 2 cubed, and so on, which is exactly what it means to be a polynomial centered at a equal to 2.